All right, good morning and happy Sunday. It's December 10th, and I'm planning on doing the Advent of Code challenge for today. Yeah, so let me share my screen. We'll start jamming here. And I'm gonna start with some music too. Okay, cool. This is an awesome song. It's Beethoven's Five Secrets from these piano guys. Okay, anyhow, let's see. What am I doing? Oh, yeah, I was looking at this. Yeah, I met this dude named Tim 7 years ago. This guy named Tim Roughgarden. Yeah, he's a super cool dude. He helped me learn how to see things algorithmically. And yeah, so I'm going to go to the advent of code and we'll start jamming here on the 10th day. So I'm going to bring this guy over here. So I'll be coding over here. All right. So it's 8:08 in the AM and we have day 10 is a pipe maze. Sounds like fun. Make directory 10. Oops. Pipe maze. Okay. Okay, 8:08 in the AM, and it's time to read the problem statement. Oops. Problem statement. Okay, so read the problem statements 8:11. So that took about 3 minutes. Oops, 8:11. Oh, 8:11 in the AM. 3 minutes. Let's read it. And then here's the game plan. Right, take this information, and these are the pipes, and we'll basically follow it, right? BFS from start S. right? That's all there is to it. Let's start the implementation. Let's get to it. All right. From input, oops, from read the input. Oh, wait, from open as input. Oh, wait. Oops, what am I doing here? Okay. For line in input, we're going to read our map basically into a two-dimensional array A, right? That'll be our matrix. A dot append line dot strip. So we don't want to have the new line character at the end of each line there. Then we'll have some start position and end position, and then we'll just follow these directions, right? So that's game plan. So start will be the index ij or ij, and where'd my music go? Hold on one sec. The worst distraction for flow is distraction, right? Come on, let's go. Choice for ij and ij for I in range. Let's do this. M and N are the cardinality input array A's rows and columns correspondingly. For ith row, for jth column, if A sub I sub j is equal to S, oops, right, that's our starting position. What is for, oops, okay. That's our start position, and then we'll have between scene. Well, let's look at the real input, and then where's S? That's our start index. So we start here, and then what is a dot? Dot is ground. Okay, that's just like an empty spot. So S, and then where can we go from S? Okay, we can't go here. So we must go to L. L is the bottom left, right? Oops. Oh, man, come on. I don't want you to connect all of a sudden. Yeah. Thank you, Apple, for nothing but a distraction. Okay. Anyhow, where were we? We were, okay, yeah, looking at the sample input, and that looks good. We'll just follow L, which is the turn to the right? And just follow that thing. And then, okay, the furthest away from it, we'll just do BFS, right? Okay, so we need a BFS Q. Q is the Q of this guy initially set to that, right? And then scene. Scene is the set of Q so far. These are ij tuples. And just make that kind of like an atomic operation. Those are associated with each other. And this guy, actually, we'll just make it a deck, right? So then we can append to the left and pop from, or append to, yeah, append to the left and pop from the right. Right, okay, so from collections, import deck, right? This is our double ended queue, and then while q ij is equal to, yeah, we should just be able to pop it, right? Q dot pop, and then case for each of these things. So we need to keep track of our current direction too, right? So let's see. Start. So we need to know. How do we know which way we're starting? Which direction we start? Are we starting? Where I'm trying to find out where we start. Do we like always go down? Ground. Guess how do we know if we're gonna go up, down, left, and right initially, right? So I guess maybe there's only some use cases that make sense. We know the dot definitely is just ground. We can't go there. So if this is a pipe, I guess we go down. But since this is an L, it only connects up above, right? So let me take a look at this real closely and then come up with a more detailed game plan as we go here as the next step. Oh, this was horrible. This isn't even aligning now. Hold on. Gotta make it at least that big. Oh, that's funny. This is my day, I forget whatever. Oh yeah, day 8. This has been running for like a couple of days now. Whatever. Just let it go in the background. I think that was trying to find all nodes that end in Z eventually. I'm pretty sure I need to find the Pisano period or some kind of repetition to make that computationally feasible. But yeah, let's start. Okay, so S. Okay, so L doesn't make sense to the left. Dot doesn't make sense to the up because it's empty. L doesn't make sense because it only connects above to the right, right above to the right. L below works, pipe to the right doesn't work. Okay, so it seems like the input is set up in a way where there's only one path. It's non-ambiguous. So, and that's a good thing. So yeah, let's just have trust that we'll just go one way. So if we're going one way, actually, it's just a single path, right? We don't need a queue, right? We just need a next step. We'll just let ij be adjacent to uv, and then we're not going to go backwards. So having a scene set is overkill. While a sub I sub j. Wait, if it is a loop, then we do want to keep track of the start. Then we'll just call this thing begin and end. Or wait, no, okay, we'll just use this set. I'm fine. Scene. Set. Okay, so then when we come back to something seen again, then we'll know we can break, right? Well, or actually, let's just do this as empty. Scene is just an empty set. Oops. While a sub I sub j not in scene. Scene add a sub I sub j, and then take the next step with the next valid step. So we do need to keep track of our direction too, right? Because if we have a pipe, I guess, no, we don't need to keep track of our last. We know the last direction can be derived from ij, right? UV will be the next step for each ij. DUDB, right? UV will be next step from each ij. DUDV will be the difference between U and I, and V and J. So next step will be to calculate UV. So we can look at all the adjacent values for IJ, and there should just be one if it's non-ambiguous. Assume non-ambiguity for the input, and we should say for U, V in the adjacent values to IJ above to the right. We'll just do this in clockwise direction below and to the left. If UV is in bounds, so does U is within 0 and M non-inclusive, and oops, this is U for the rows. V is within 0 to in non-inclusive for the columns. Okay, so actually I might want to have each individual case. I think so. Okay, let's consider this for each individual case. Okay, so if up, actually, hold on, how do I want to do this? I think, right, our input is it's up, it needs to be a pipe, or it needs to be a 7. Right, up can be a pipe, a 7, up a 7 or a F. If we go up this way. Well, there could be two potential ways, I guess. All right. Our input only has one, but this input has two potential ways, but it doesn't really matter. The two potential ways, okay. So I see if there are breaks in the road like this, then DFS isn't going to work. Okay, we do need BFS then. Okay. Initially, I was thinking, okay, that might be overkill, but actually, this is fine, right? This will be our Q, and what's been in queued will be in the scene set. BFS to the greatest depth, and then the greatest depth, how many steps, right? Okay, we'll do that. Q, scene, and then our depth. Scene is a set of values, I, J, and Q, right? Depth will be 0. Okay, and then, yeah, this would be a deck. Oops. Okay, so the current character compared to the next. How do I want to simulate movement? guess we'd want to potentially go in each direction, right? Okay. Just try to move everywhere we can. So can I go up? Nope. Can I go right? Yep. Can I go down? Yep. Okay. Just answer that question, right? Where can I go? Right. That sounds good. I don't think we need DUDD. Okay, so these are the next steps. Like, and then the next step, our next question is, can we go there? 1K depth at a time. That should not be reevaluated, right? So this is 1K depth at a time. This is our goal. Oops. Depth. That's how many steps we take on a BFSQ. So we can't go any further away from the starting point. Okay, so then for ij equals q dot pop. All right. Oops. What's going on here? Why is depth expected indented block? It is indented though. Oh, okay. This is because of this white space. Okay. Still work in progress. Okay, so this just says it's inbounds. Okay, so let's go through each of these use cases. It's kind of easier to see in this picture. So let me just grab this. 1, 2, 3, 4, 5, 6, 7, 8 potential cases to consider. Oops. Let me stick this up here. And then instead of going back and forth, I'll just grab this and then implement it here. Okay, so maybe I should consider these all in different loops then, or different. So let me ask myself this question, right? For above, what are possible use cases, right? So we know it's F, a pipe, and a 7, right? F, a pipe, and a 7, right? And then for below, same thing, right? What are the possible use cases? And those would be L, pipe, and J, right? And then another question is for left, right? Same thing. What are the possible use cases? And that would be L, a dash, and F. And then for right, possible use cases are 7 dash and J, right? Okay, so then we just need to code this, right? I think so. Okay, let's do this. Up. UV equals I minus 1 J. If 0 is less than equal to U, then M, and 0 is less than equal to V is less than N. All right, it's in bounds, and A sub U sub V is in. Let's do this. Let's just create a set for now. We'll refactor this later to make this self-documented code up. Right, so this will be the set of the characters F pipe 7. Similarly, down with this set of characters L pipe and J. Left with this set of characters L dash F. Right to be the set of characters. Oops. 7 dash J. It's in up. Then we're good to go to add that to the next case. Q to append left, right? Basically just indicate at the end of the queue, UV as the next state. Okay, so we don't need up as a comment, right? This is self-documented code. UV for down will be I plus 1J. If it's in bounds, just copy and paste this, right? And it's in down. And yeah, we'll refactor this code hopefully to make it a little bit better. This is kind of ugly, but whatever. The process of creation sometimes a little bit sloppy. That's okay. It's an imperfect process. Okay, left, comb to the left. Okay, and then right. Oops. G plus 1. This guy, sticky there, right? Okay. Q. And then need to add these things to scene as well, right? Otherwise, we're gonna be in trouble. Scene to add UV. Pin this on each of these guys. Boom, boom, boom. Okay, let's run this and see what happens. Hold on, keep track of what time it is too. It's 8:30. 8:36. Oops. So it took about 25 minutes for the implementation in Python 3. Let's see what happens when we run this thing. Oops. Okay, uh-oh. Index out of range. What? Oh, okay. I better put some input in here. Oh, I better do this start too. Okay, stick that there. Let's try this again. Whoa. That. Really? Okay. I'll do this the hard way then. Set to the tuple ij for ij in Q, right? Come on. Whoa, this thing is like it's taking a long time. This doesn't look good. Oh, I need to, yeah, okay, hold on. It's getting stuck. So I need to make sure ij is not already seen, right? If the tuple ij is in scene, right? We'll just continue. Oops. Well, oh, oops. Hold on. It is already seen because I added here. Okay, so added to scene here then. I think that's okay. Yeah, all right. Well, let's see what happens. Added to scene here. Okay, so scene will just be an empty set. Let's just do this. Q scene depth. Empty set and the depth of 0. These are like tightly coupled to each other as a tuple. Oops. Okay, so add this to scene as we pop it off the queue. Consider all possibilities of where we can go. All right, let's try this again. And it says 6. Set. 1, 2, 3, 4, 5, 6. Now, what's this? I wonder if maybe I should overwrite the input on each iteration. Let's do this. K is the cardinality to Q, right? For K dev. And okay, so actually, let me keep track where I'm at. It's 840. This thing is not working like I want it to, right? 840. Debugging. Kth depth. Or the case size depth. Q size K. Okay, so that's how things look. And then now I have a feeling like if we put something in the queue, but we don't mark it as seen, we'll just keep continually putting stuff in the queue. So that seems concerning. I guess we pop it out and maybe it's okay. This is what's been seen so far. Seen is values not in the queue yet. Okay. And then we can derive from this information where we end up going for each depth. Okay, so we start off at 1, 1, which would be this guy. That looks good. Didn't we go to 1, 2? That looks good. And 2, 1. That looks good. Depth 1. Okay. 3, 1, 1, 3. Depth 2. Okay. Here. Yeah, the key's getting filled up with junk. Okay, and UV. It's not insane. Okay, I think that's making us do too many iterations, right? And then 1, 2, 3, 4. We don't go anywhere, then we don't increment the depth then, right? Okay equals true or false. How about def plus equals and okay. And okay is true if and only if we actually go somewhere, right? Okay equals true for each of these guys. Boom, 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 boom. Okay, that looks good, right? We go 4. 1, 2, 3, 4. Okay, let's try this one. And we're saying same loop. Okay, well, let's see what happens when we run it on this guy. Oh, it doesn't go anywhere. Okay, let's just double check. Oh, this is not right. This is not. It's saying it's the same loop. Sketch shows the same loop as above. Okay, my logic's wrong then. J. We can only go to another J if the one above it is a pipe or a 7. Okay, some additional constraints. And I go to the next J. Okay, it's a good thing I ran this. All right, and checking where we're at here. Still debugging, right? Getting there though. I think we're getting close here. Should be able to wrap it up, right? So if it's a J, we need a pipe or a 7 above it, right? So pipe is 7 or F. Okay. Okay, so we go from up to down. Okay, A sub I sub J is in up and A sub V is in down. Similarly, we can go up from a down. Right, so the last one is down and the current one is up, right? Last one is up and the current one's down. Similarly, from left, I'm gonna move right. We have to be at L or F. Or wait, from the right. The right. Okay, from the right. A sub I sub j is in right. Oops. A sub I sub j is in right, and then this one be A sub I, oops, I sub j is in left. That guy's in right. Okay. Uh-oh. Oh, uh-oh. Let's do this. Um, we need to define these guys all up here so I can use them down there. Oops. And okay. Here we see, okay, it's down to up to down, right to left, and left to right. Okay, so it is pretty much self-documented, right? It's okay. Down, left, right. Okay, let's run this again. Uh-oh, it didn't go anywhere. Oh, if it's not the start, okay. Or it's the start. The start. We have an exemption. Or, or a sub I sub j equals start. Or a sub I sub j start. Okay. Okay. Yay, that was good. Okay, so this is for this input, right? Which is the same loop as this input. Better double check we don't have any regressions by running this again. Okay, that looks good. It'll be the first time I broke something, right? Okay, let's make sure this one works. So we've seen this guy is for this one is what? 8. Okay, so the 8 should be this guy. 8. Okay, that looks good. Let's try it for the input puzzle and see what happens here. Okay. Whoa, the input's pretty big. Okay, this is taking too long to print. So I need to get rid of my print debug statement. Where am I printing? Oh, holy cow. Yeah, get rid of those. All right, here we go. 7173 seems plausible. It's 850. We're gonna submit it. Yay, okay, that worked. 850. That's 851. Part 1 accepted. Yay. Okay, so that took, holy cow, that took like 43 minutes. 43 minutes. Right, so that was to read the problem statement, come up with a game plan, which changed along the way, right? Right, changed like slightly, right? Right, that is during the implementation. So that's cool. Okay, and then we did validation. Validation on small input, fix bugs. Oops. Oops. Then submit. So what's the upshot? That's not on the first try, right? Nope. Not even close. That is like just totally failing forward, right? It's cool, right? It's pretty decent code too. I might clean it up here in a little bit, but let's read problem on part 2 and see how bad the code is or how good it is based on how much we have to refactor it for the second part. Okay, so it's 8:52 a.m. Oops. Okay, so just leave that like that for now. All right, start reading the problem statement. All right, part two. Oops. Read problem statement. Okay. Why are these ones not in the loop though? It looks like it's in the loop to me. Oh, okay, because there's a space between the outer edge. And okay, that makes sense. Okay. This whole thingy. Squeeze the pipes. Squeeze the pipes. Yeah. Oh, weird. Okay, I mean I can see this narrow path being okay. I'm gonna look at this input a little more closely. Open this guy up here. Advent code. Is it Okay, so to squeeze the pipe means that the entry points from above could be F and L, or F and 7. The entry points from below could be L and J. The entry points from the right and left could be a horizontal dash. F and L for the right to left. 7 and J from left to right. Going from left to right. This whole thing's helpful. Right, so entry points from right to left, right to left, right could be actually just the boundary. Okay, so maybe I'll just copy and paste this code, but the starting points would be the outer edge, out of bounds. Part one. I'll come back and refactor this later, maybe. All right, boom. In this case, we're going to use inversion. Part two, use inversion to derive the count of spaces inside the loop. That is, we count the total number of spaces, right? Characters at the dot. Then we use BFS from outwards in, right? Initially from all OB cells inwards to count the amount, the number of spaces adjacent to the outside, right? Then we derive the kind of spaces inside the loop, right? Return, right? Spaces inside the loop is then total spaces minus spaces outside, right? The loop. Okay, so that's our game plan. Do total inside and outside. Outside will be 0 initially. Count those as we go through those. The other one would be the length of ij tuples for I in range m for j in range n if a sub I sub j is equal to dot. Inside then equals the total minus the outside. And that's where we use inversion. And this is the goal. And for part two, would be how many nodes are counted as inside. BFSQ will be a deck, sort of part one. And it'll be all ij tuples for I in range. And for j range. Oh, actually, no, hold on. We want these to be the values in the outer edge. Okay, right. So Let's do this. Do top and bottom, top, bottom. Triples -1 and J for J in range in bottom is M J or J in range in left and right. So left will be -1. Okay. 1, 2, m-1, non-inclusive, since those are the top and bottom correspondingly. And then right will be N and I, right, for I in range. Again, 1, 2, -1 correspondingly, since those are in the top and bottom already. Okay, so our Q will be a deck of these guys. Top plus bottom plus left plus right. Okay, concatenate together, right? I'll let this part out for now. Just run this part on a small input. This might be our most simple example. Well, if it's a dot, it's also good. Small input. Outside. Total. Okay, so print. Oops. Total. Print. Outside. Okay, then we'll also want to print our Q. Size J tuples for J. Q. Okay. This looks right. So let me print him and in first. And n is n, right? The dimensions of our matrix is the rows and four columns correspondingly, right? 9 and 11. So 11 and 0. Is there no 11, 0? Because of catty corner, right? Oh, okay, yeah, so we don't want -1, -1. 0, 2 -1. Okay, so this logic doesn't make sense though, right? I want to be all the way here because that's not already there, right? Left and right. So left and right would be missing -1, 0, isn't it? Or no, -1. and m minus 1, -1, m minus 1, -110. -110 is missing, right? -1 and 10. Wait, is there? Hold on. One, two. Let's do this. This will be easier to see. Let's do this. Print. Oops, top. Oops. Top. Bottom. Left. That'll be easier than seeing the whole queue all at once. Top is -1 row, right? For 0 to 10 inclusive. 0 to 10 inclusive be columns. 0 through 10 inclusive. That was good. Bottom is the same thing as 0 through 10 inclusive, but then it's going to be M. Okay, that's good. Left is 0 through 8 inclusive, right? Okay, -1, 0 through 8 inclusive. Okay, this seems to look great. Good to validate the input. Okay, and then that looks right. Okay. Okay. Well, Q. Just mark everything as seen in the queue. IJ or IJ in the queue. I think we can take a lot of this logic and reuse it too, and then we'll refactor it later on here. Q. This time we don't have to do it per depth. IJ equals Q dot pop. Oops. If IJ is in scene, continue. Otherwise, you would add IJ, IJ. That guy's not seen. And the up ones are F and 7. We're saying down to up. As long as the next one's at up or a sub u sub v equal to a dot. It's empty space or it's up. What's this? What is that guy? Oops. Okay, so it's either up or it's a dot. Guy is either down or it's a dot. It's really have to be go to the left. Right. So these would be the dots. Okay. I need okay here. Right, because we're not incrementing the depth. Not even really keeping track of the depth. We're only wanting to count characters actually. So if a sub I sub j, oops, hold on, j, as we add them to the queue, maybe we'll count them as we go. Count of inside plus equals a sub u sub v is equal to a dot pass into an integer, that predicate inside or outside, yeah, outside, inside's derived from outside of total, right? Okay, so outside is that guy, and that guy, and I'm pretty sure I can refactor this to just be here in one spot, but for now, it's good enough. Let's see what happens. 53. Wait, hold on, not outside is 0. That doesn't seem right. Let's just debug this here real quick and see what's going on. And then when I call it a day, right? We're gonna code it for over an hour, or just take a break. Okay. Put a breakpoint in this guy. Oh, oops. Okay. It's because of this. Initialize the set, right? Okay, let's run this and see what happens here. Negative 22. I mean, it's just 22 and I calculated backwards. It should be 4. Oops, okay, so I'm pretty far off. I'm not counting enough outside. Or no, I'm counting too many outside. Too many outside. It's not insane. Oh, okay. So I do need to make this calculation just once. Okay. So the logic is wrong. The code is verbose. And let's do this. A sub u sub v is in bounds. Roger. response instead of every time. Oh, oh, okay. Let's run it this way. Okay, that was good. Okay, total outside is 49. It's 4, so that's right. Let's make sure forward for this input too, where it's squeezed. Handicap. Oh, oops. Not like this. Uh-oh, that's not right. Saying all of them are outside and there's none inside. Okay, so my logic is not right then. Maybe I have to consider this completely differently as connected components or some other different graphing type algorithm. But I thought VFS just from the outside would work. Dang. Okay, well, that kind of sucks, but I'll come back to this later on. I'm gonna go spend some time with my family and go hiking or something. Spend some time away from this computer. Uh, it's an entry point. What's it? Yeah, I'm pretty sure I'm kind of close, right? It's just something pretty basic like this, but I'm kind of worn out, right? I'm gonna take a break and come back. 9:20 point of reached point. Oops, point of diminishing returns. Right, I'm just kind of like staring at this thing. Interestingly, though, if we look at this and struggle sufficiently and then take a break, the subconscious brain will work on it on our behalf and be like making a sandwich or something and have like an epiphany. It's like, oh, huh, what if you do it this way? Like make my life easier, right? So that's what I'm hoping for. Well, not hoping, but I'm kind of counting on either taking a break and having some insight or doing some additional Pomodoros and looking at this again. And the logic is somewhat like this, though, but it's obviously not correct, right? I'm not able to get the squeeze use case, so we'll mark ourselves as this, right? To do properly, oops, properly handle the squeezed use case, right? And we'll say that for to be continued later on today or later on sometime. All right, catch y'all later.